6b. Now let's do some algebra that we've done in the past when solving for vertical asymptotes, just as a review. Okay, so here we have find the vertical asymptotes for, and I'm going to give different examples. First one, f of x equals x plus 3 over x minus 3. Remember, to find the vertical asymptote, we have to look at our denominator. Our denominator cannot equal 0. X minus 3 cannot equal 0. So we solve for that. X cannot equal 3. Since x cannot equal 3, that's where the vertical asymptote is going to be. So our vertical asymptote is going to be x equals 3. That's the equation of the line. Okay, let's do another one. Okay, how about this one? F of x equals x squared minus 1 over x squared minus 2x plus 1. Now remember, when we did limits, we had to factor first. So we're going to do the same thing here. We're going to factor first. Difference of two squares, x plus 1 times x minus 1. Here we're going to factor this, and we get an x and an x, and minus 1, minus 1. So we can cancel our minus 1's. And what do we notice? What's left? We have x plus 1 over x minus 1. Now to find vertical asymptotes, we look at the denominator. Okay, we know x minus 1 cannot equal 0, so x cannot equal 1. Therefore, our vertical asymptote for this problem is x equals 1. Okay, let's do another one. Let's say f of x equals x squared plus 2 over x squared minus 1. All right, this isn't factorable, but we can keep going on this one, or we can just look at it this way. This right here we know cannot equal 0, right? So let's write that. X squared minus 1 cannot equal 0. So x squared cannot equal 1. So x cannot equal plus or minus 1 when you square root both sides. All right, so we have two vertical asymptotes for this one. That's x equals 1 and x equals negative 1. Okay, one more question. I'm not sure we have enough room for this. I'll try to write smaller. Okay, here we have f of x equals x squared minus x minus 2. That's in the numerator. And in the denominator, we have x cubed minus 2x squared minus 3x. Okay, like before, we're going to factor first. For factoring the numerator, we have x minus 2 times x plus 1. And factoring the denominator, we factor out an x. And then when we're done with that, just to save time, we have x minus 3 times x plus 1. All right, so we can see that these are going to cancel right here. Now you may say, well, why can't we say x equals negative 1 to also be a vertical asymptote? And I'm going to show you that in a minute. But canceling this out, we have these right here. So we know x cannot equal 0 and x cannot equal 3. So our vertical asymptotes for this problem is x equals 0 and x equals 3. Now let's look at this one. We say, well, why? Why don't we have a vertical asymptote at x equals negative 1? We're going to ask that question. Well, I'm going to go up here to make some room to answer that question. Remember, we talked about limits. Okay, so let's look at the limit as x approaches negative 1. Let's see, where are we? If we take the limit of f of x in our problem, we went ahead and we got all the way down to this right here, which is x minus 2. I'm just going to write x squared minus 3x. As x approaches negative 1. Does the limit exist just approaching negative 1? That means from the right to left. We're just going to look to see if it exists at all. Okay, if we put a negative 1 in there, we're going to get a negative 3. And if we put a negative 1 in there, we're going to get a positive 4. So this is the limit. If we have a limit, that doesn't agree with what we talked about earlier. It must be plus or minus infinity in order for there to be a vertical asymptote. This right here must equal this. Since it did not, it had an actual limit, then there is no vertical asymptote at x equals negative 1. Okay, a couple more examples, and then we'll go on to 3.6c. These I'm just going to write and show you to save some time. So here's an example. F of x equals log x. F of x equals log x. Okay, if we were to graph log x, remember log of 10 is 1, log of 1 is 0, so log of 1 is 0, log of 10 is 1, log of 100 is 2, and it grows slowly like this, and slowly like this, and it approaches the y-axis. It never gets there. So what is our vertical asymptote in this picture? Our vertical asymptote is x equals 0. Okay, now that's true if we also have f of x equals ln of x. We're going to have the same vertical asymptote for both of those. Okay, let's look at another example. How about f of x equals 1 over square roots of x? We know x cannot equal 0 in this case as well. So our vertical asymptote is going to be x equals 0.